Hi everyone, my name is Wu Xuanshi, a PhD student from Wuhan University. I'm glad to present our work, Prototype Reminiscence and Augmented Asymmetric Knowledge Aggregation for Non-Exemplar Class-Incremental Learning. Incremental learning allows humans to continuously learn new knowledge while maintaining existing knowledge. When a neural network learns a new task, it tends to adapt its parameters to the new task so that it almost forgets previously acquired knowledge, which is called catastrophic forgetting. Class incremental learning has been proposed in response to the problem of catastrophic forgetting. In the setting of CRL, the algorithm is to continually learn from the string of sequential data and classify all the classes observed so far at any time. The most common solution is the replay-based method, which stores a small portion of old data along with the new data to jointly train the model. However, in some scenarios, storing data is undesirable due to memory constraints or privacy concerns. Therefore, we focus on a paradigm which learning without saving any samples is called non-exemplar class incremental learning. Some recent works have proposed a prototype-based method for NECIL. The saved prototype is then used for joint training with new data. This is a more privacy-secure and memory-friendly solution. Some works propose to oversample the prototype or augment the prototype by Gaussian noise. As shown in the figure, it suppresses changes in the decision boundary. However, for incremental learning, training the model on new data causes the representation to keep changing, and then the feature distribution modeled by simply adding noise becomes out of date. In order to improve the plasticity of the model, some works have introduced self-supervised learning to NECIL. It forces the model to obtain task environment representations to improve its generalization ability. However, only the predictions of the non-augmented classes are considered valid during testing, which leads to a large amount of information that is valuable for the current task being discarded. To address catastrophic forgetting, we propose prototype reminiscence. It generates old class features by a simple yet effective interpolation operation between the saved prototypes and the new class features, thus modeling the distribution of the old class features while effectively avoiding the lapse of the decision boundary. It injects the newly learned knowledge when reshaping the old feature distribution, which can mitigate the negative impact of prototype updates. To fully use the knowledge learned by SSL, we perform asymmetric knowledge aggregation on the classifier. Here, a refined classifier is introduced, which only needs to distinguish non-augmented classes. For past tasks, valid information are extracted. For current tasks, information of all augmented classes are aggregated. Then aggregated knowledge is transferred to the refined classifier. The model's understanding of the new task can be improved by asymmetric knowledge aggregation. Here is the overall framework of our method. We report the average incremental accuracy on 3 benchmarks. Our method significantly outperforms the SOTA methods. Here we show the accuracy change curves. Our method is superior at almost all phases. We also perform ablation studies to analyze the contribution of the different components to the performance of our method. By comparing the confusion matrix, our method shows better overall performance without favoring old or new classes. Figure on the right shows the AKA improves the model's understanding of new tasks as non-destructively as possible. On the one hand, the performance degradation in the initial task caused by AKA is insignificant. On the other hand, the discrimination of new classes is notably improved. That's all. Thank you for your attention. Attached below is our project address and QR code. Everyone is welcome to visit.